Polynomials. Polynomials. The title of the new section. Prior to defining a polynomial, poly means many. Before I define many of something, I should define what one of them is. And that's called a monomial. Monomials can be written in a particular form. Can be written in the form ax to the m. And I have to define what a, x, and m can be. A can be any number. It can be any number. X can be any variable. That is, it didn't have to be x. It could have been y, or v, or a, or some Greek letter. Doesn't matter. M. M can either be 0, or 1, or 2, or 3, etc. I think that's called the whole numbers. M cannot be a fraction. It cannot be negative. It can be any variable, too. M can be 0, 1, 2, 3, any of those numbers. But for example, negative 3x to the 9. We'll call this standard form. This is in standard form. Here's a number and a number. Here's a variable, and here is an allowable exponent. This is a monomial. If you have 7 over x to the 4, this is a monomial. Because if I bring the x to the negative 4 to the numerator, it becomes 7x to the 4. Here's my any number, here's my any variable, and this is an allowable exponent. This is a monomial. I never said you have to be in this form, ax to the m, to be a monomial. It doesn't say that. It says it can be written in that form. I wrote, this is not in ax to the m form. But I can write it like that. Now, if this 4 in the bottom, I'm going to modify it. If this 4, if it was just 4, then when I bring it to the top, it'll be 7x to the negative 4. Here's my any number, here's my variable, here's my exponent. But that's not an allowable exponent. This is not a monomial. Why? I couldn't write it in ax to the m form where m was one of those allowable numbers. So it's not a monomial. Now, here's one where it gets to be a little bit tricky. And we just have to talk about it for a moment. The constant. 7, negative 9, the square root of 11. Well, 7 is 7 times 1. I want to change the way it looks. I want to introduce an x. I want to change the way that looks. That's code for I want to multiply by 1. You must have that down. I want to change the way this looks. That means I'm going to multiply by 1. And you need to remember that x to the 0 is 1. This is 7 times 1, which, yeah, of course, 7 times 1 equals 7. Here's any number. Here's my variable. Oh, that's an allowable exponent. This is a monomial. Now, there was nothing special about 7. It could have been 17. 17 is equal to 17 times x to the 0, which is 17 times 1. This is any number. Here's my variable. Here is an allowable exponent. You didn't like x for some reason. You like k instead. So you have 17 times. Well, k to the 0 is 1. So that equals 17. 17 times 1 is 17. Here's my any number. Here's my variable. Here's my allowable exponent. That is a monomial. That is a monomial. Okay, let us now define polynomial. A polynomial is the sum and or difference. Sum means add, difference means subtract. It's the sum or difference of monomials. The sum or difference of monomials. That is, you can add monomials, you can subtract, you can add some, subtract others. Doesn't matter whether you add or subtract them. So, let me erase the top, and I'll put down some examples, and you have to decide if they're polynomials or not. 3y to the 7 minus 2y cubed. To be a polynomial, the variable has to be the same. The variable has to be the same. And they are. These are the terms. Each term must be a polynomial. Sometimes we add, assuming that's a polynomial. Sometimes we subtract monomials. Okay, we're either adding and subtracting. Well, the first term, this is a polynomial. The number times the variable raised to an allowable power. It's just the power that's the key. Doesn't matter what that number is. 2 over 7 is a number. The number times y to an allowable exponent. The number times the same variable to an allowable exponent. The next one, we have to think just a moment. It's a number times y is no power. It's understood to be 1. This is a polynomial, and 1's allowed. That is a polynomial. Now, suppose you have y to the 7 over 2 minus 3y to the 4 plus 2 over y to the 7. This is a polynomial because so each of these has to be monomials. The first one is. Dividing by 2 is the same as multiplying by a half. This is 1/2 times y to the 7. Here's my a, here's my variable, here's my allowable exponent. Here's my number, here's my variable, and here's my allowable exponent. This is not a polynomial, excuse me, because when I bring this to the top, here's my number times my variable, but that power is not allowed. Sorry, it's not a polynomial. It's not a polynomial. It is not a polynomial because of the first term. The first term is fine. The first term is fine. You can always convert division to multiplication. Instead of dividing by a half, instead of dividing by 2, you can multiply by the reciprocal. Instead of dividing by 2, I can change that division to multiplication. so long as I flip over the bottom number. And 2 is 2 over 1. And multiplication commutes. That's 1/2 times y to the 12th. And to look at it more carefully, when you multiply the numerators, you get y to the 12th. And you only have one denominator. If you insist on putting the 1 there, 2 times 1 is 2. This equals 1/2 y to the 12th. Here, 3 over x squared plus x to the 4th minus 7x to the 5th plus 11. These are the terms. This one's a monomial, so is this one. This is not a monomial. That is the whole thing. Is not a polynomial. Each and every term must be a monomial. You have 3x squared times 4x to the 7th minus 3x to the 11th plus 4x to the 3rd. This is not polynomial. The terms are separated by addition and subtraction symbols. And I'm not going to argue that this is not a number times x to an allowable power. And I'm not going to argue that this is not a number times x to an allowable power. I'm not going to argue that. I won't argue that that's a monomial. I can't argue then that that's a monomial. But a polynomial is the sum or differences of monomials. This is a product. This is a product. Oh, well, actually, I'm going to take back what I said. It is a polynomial. Why? Because I can multiply those two. Actually, that's the next topic, but we'll sneak it in now. 3 times 4. 3 times 4 is 12. And x squared times x to the 7th, that's x to the 9th. Sorry, that's a monomial. That's a monomial. It's a number times x to a power minus another monomial plus another monomial. This is a polynomial. Sorry. You multiply two monomials, you will get another monomial. Why? A times x to the m, assuming the variables are the same, times any number. I don't want it to be the same as the first number. Doesn't have to be. Times x to some allowable power. Call it n. Well, a times b is ab. X to the m times x to the n is x to the n plus n. Well, each of these numbers are at least 0. So when I add them, they're at least 0. And when you add two integers, you get an integer. That is, this number is going to be 0 or 1 or 2, etc. It can be 0. If both of these are 0, I'll get 0. It can be 5. I mean, this could have been 4 and this could have been 1, or this could have been 2 and that could have been 3. You add two integers, you get an integer. If m is greater than 0 or equal to 0, and n is an integer greater than or equal to 0, when you add them, you'll get greater than 0 and n. You get greater than 0 plus 0, which is 0. M plus n is greater than or equal to 0, and since m and n were both integers, their sum will be integers. So yeah, you can multiply. I was greatly mistaken. The next thing we want to talk about is how to find the degree of a polynomial. Find the degree of this polynomial. 3x to the 7th minus 2x squared minus 3x to the 13th plus 4x to the 5th. You look at the exponents of x. You look at, or y or z. You look at the exponent of the variable, and you decide what the highest number is. Between the four numbers are circled in red, 13 is the largest. The problem is done. The degree is 13. What is the degree of 7x minus 9? Well, here you have to be a little bit clever. You have to see things that aren't there. X is the same as x to the 1. And 9 is the same as 9x to the 0. So now I see my exponent. The largest one is 1. The largest one is 1. Largest exponent is 1. We have the degree of 3x to the 7 minus 11 plus 2x cubed minus 14x plus 9x to the 13. The degree is going to be 13 because the degree of the first term is 7. The degree of the second term is 0. The degree of the third term is 3. The degree of the fourth term is at understood 1. And the degree of the fifth and last term is 13. Between 7, 0, 13, 1, 7, 0, 3. That's the 3, of course. Between 7, 0, 3, 1, and 13. 13 is the largest one. The degree of a polynomial is the largest exponent. If somebody asks you, what is the degree of 9? You should say 0, because 9, you have to change the way it looks. You have to get x. Well, you can only multiply 9 by 1. And here's a way of writing 1 that has an x involved, and an exponent. So it's 0. And of course, the variable could have been something else. Back to the last one, the variable could have just simply have been y. It doesn't matter. The degree is still 13. Okay, the degree is still 13. Now, we want to be able to write the polynomial in descending order of the exponents. That is, the largest exponent first, and the next largest exponent second, etc. So you have 7x plus 3x to the 9th minus 13x to the 4th plus 2x cubed. Well, first thing, you have to arrange the powers in order. First, you have to be able to see the powers. There's a 1 here. Between 1, the order of those numbers, the order of 1, 9, 4, and 3. Well, the largest one is 9. The next largest number is 4. The next largest number is 3. And the smallest one is 1. So I write the x to the 9th first. 3x to the 9th. Then I write the x to the 4th next. Minus 13x to the 4th. Then cubed. I write plus 2x cubed next. And then the 1, I write plus, understood to be plus, I write plus 7x next. And there it is. This in descending order. Write it in descending order. The exponents, they go 9 to 3 to 4, to 3, and then to the understood 1. They went down. They decreased. Try another one. Suppose you have 11x to the 7 minus 2/3 x to the 9 minus 31x to the 11 minus 2x to the 4 plus 9. Now, remember the 9 is really 9x to the 0. Okay. Your job now is to write the x, to figure out what the exponents are, and then write it down from largest to smallest. Between all the exponents I see, namely the 7, the 9, the 11, the 4, and the understood 0, the 11 is the largest. So this is equal to negative 31x to the 11th. And then 9 is the next largest exponent. So it's minus 2/3 x to the 9. And then 7 is the next largest. Remember, there's an understood plus in front. However, let us change it. What if it were negative 11x to the 7th? So I would write down minus 11x to the 7th. Then 4 is the next smallest exponent. And finally, 0 is the least exponent. So I won't even write the x to the 0. I'll just write 9. And there it is. The exponents are in descending order. Descending means decreasing. They went from largest to smallest. Okay, now, sometimes you want to fill in the missing terms. In particular, when you're doing long division of polynomials, it might be very helpful to fill in the missing terms. So, when you give your polynomial, it'll already be in descending order. And if it weren't, then you should put it in descending order. Not go so high. So if you have 7x to the 5th minus 3x to the 2nd plus 11x, and that's it. The degree is 5. Okay, so instructions are fill in the missing terms. Now here, you have to have a strong command of adding 0. You can always add 0. 7 plus 3 minus 11 plus 9 is equal to 7 plus 3 minus 11 plus 9 plus 0. Plus 0 again if you like. In fact, it equals 7 plus 0 plus 3 minus 11 plus 0 plus 9. I can insert 0 wherever I want. I said 7 plus 0. And then I added 3. And then I took away 11. And then I add 0. You can add 0. It won't affect things. You can add 0. Okay. The degree of this is 5. So you must have an x to the 5th. You must have an x to the 4th. You must have an x cubed term. You must have an x squared term. You must have an x term. You must have a constant term. Well, I'm looking here and only here. How many x to the 5th do I have? The answer is not 1. The answer is 7. How many x to the 4th do I have? I have none. 0 times x to the 4th is 0. I just added 0. And how many x cubes do I have? When I look here, I don't see any x cubes. I have 0 of them. So I can add on 0 x cubes. How many x squares do I have? Oh, that I know. I have negative 3 of them. How many x's do I have? Plus 11. What's my constant? 0. Here it is. You have to have an x to the fifth, an x to the fourth, an x cubed, an x squared, an x, and a constant. Some of these terms, which were missing in the line above, they just equal 0. 0 times x to the fourth. Once somebody asks you how much is 0 times, you don't even have to listen to what they say next. You say 0. If somebody says, I'll give you $100 if you tell me what 0 times is. You didn't even hear what I said. You didn't even hear what I said. Okay, what is 0 times? You should know the answer. It's 0. If it's 0 times and you didn't hear what they said, or if you couldn't read what I wrote, how much is 0 times? Okay, that doesn't look like a number, but you know the answer is 0. You don't have to be able to read that. 0 times x to the fourth is 0. 0 times x cubed is 0. And that's an example where we fill in the missing terms by adding 0. Let's do one more. The initial equation that you're given, or the initial polynomial that you're given, will not necessarily be in descending order. Okay, so you have negative 2x to the fourth plus 7x to the sixth minus 2x cubed plus 14. So the degree of this is 6, because between all the exponents that I see and even the ones that I don't see, the largest one is 6. So you have to have x to the 6th. Why? We have 7 of them. But when I look here, I don't see any x to the 5th. So I guess we have 0 of them. But I do see x to the 4th. We have negative 2x to the 4th. Oh my, I even see x cubed. We have negative, include the sign. We have negative 2x cubed. I don't see any x squares up here. So we must have 0 of them. I don't even see any x's. We have 0 x's. But I do see a constant, or I do see x to the 0. I have 14x to the 0, and there's no point in even writing the x to the 0. And there is your answer, in descending order, and the missing terms are filled in. You have to have an x to the 6th, an x to the 5, an x to the 4, an x to the 3, an x to the 2, an x, and a constant. When they say, fill in the missing terms. Okay. Now, the next thing we're going to talk about, you want to lead up to adding polynomials and subtracting polynomials. So the next thing we're going to talk about is how to identify the type of terms. What type are terms? Identify the type of term. And this is very, very simple as long as you remember the rule I'm telling you. It's very simple. 3x to the 5th minus 4x cubed plus 7x to the 9 minus 11. Well, let's write down the terms. 3x to the 5th, 4x cubed, 7x to the 9, and 11. Okay? If you just ignore the number, that's the type of term it is. What type of term is this? It's an x to the 5th term. What type of term is this? Just ignore the number. It's an x cubed term. What type of term is this? It's an x to the 9th term. Here you only have a number. That's called a constant. What type of a term is 11? It's a constant. Just ignore the number. In 3x to the 5th, just ignore the number. That's an x to the 5th term. 4x cubed, what type of term is it? Ignore the number. It's an x cubed term. 7x to the 9th, oh, that's an x to the 9th term. 11 is just a constant. That is how you identify the type of terms. Ignore the number. Okay, just ignore the number, and you will know the type of term. The type of term is 3x to the 5th. Ignore this 3. It's an x to the 5th term. 4x cubed. Ignore the 4. It's an x cubed term. 7x to the 9th. Ignore the 7. 11. Ignore the number. Nothing left. Oh, it was a constant. That's the type of term. Constant. So I answered it. The first term is an x to the 5th. The second term is an x cubed. The third one is x to the 9th. And the 11 is just a constant. So now we're ready to really move on. You want to identify the like terms. You want to now identify the like terms. Terms are alike if they're exactly the same type. You find out the type, and if they're exactly the same type, you say they're alike. They're alike. And now we're going to identify the like terms. 3x to the 7th minus 4x to the 5th plus or minus 2x to the 7th plus 11x cubed plus 10x squared. Well, this term is an x to the 7th because I ignored the 3. This term is an x to the 5th term. This is an x to the 7th term. This is an x cubed term. And I meant for the last one to be 10x to the 5th. When I ignore the 10, I get x to the 5th. When I have the same type of term, they're alike. For example, the first term and the third term are alike. Why? Because they were both x to the 7th. And the second and the last term, they're alike because they're both x to the 5th. You identify the terms, and then you see which ones are exactly the same. And you say, oh, they're alike terms. This is an x to the 7th term. This is an x to the 7th term. They're like terms. And you combine like terms. For example, to add these. What they're doing, or to combine them, what they're asking here is two arithmetic equations. They're asking these two questions. How much is 3 minus 2? And how much is negative 4 plus 10? If you owe the bank $10 and you give them 10, I may have said that wrong. If you owe the bank $4 and you give them 10, you're now up 6. Your balance will be $6. Because it's the same as 10 plus negative 4, which is 10 minus 4, or 6. That is, they just ask, we have three different types of terms. X to the 7th, x to the 5th, and x cubed. And we do the arithmetics with the numbers in front of the like terms. This term and this term are like. So we do 3 minus 2. 3 minus 2 is 1. So we have 1x to the 7th, or just x to the 7th. Now, 4x to the negative 4x to the 5th, plus 10x to the 5th. we add the numbers, we combine the numbers in front of the x to the fifth. Namely, negative 4 plus 10. Negative 4 plus 10. 6. 6 what? X to the fifth. 6 is understood to be positive. Plus 6x to the fifth. Then there are x cubed terms. Fact is only 1. We just have 11. 11 is understood to be positive. Plus 11. It was just 2 arithmetics that we had to do. We just had to do 2 arithmetics. Try one more. Suppose you had 17x to the 4th minus 2x to the 6th plus 3x to the 4th plus 10x to the 6th minus 2x to the 4th plus 3x to the 10th. We have x to the 4th terms. We have x to the 6th terms. I already said x to the 4th. I already wrote down x to the 6th. I already wrote down x to the 4th, x to the 10th. These are the different terms that we have. We just combine the numbers in front of the like one, like x to the 4th. We have 17, and we are adding 3. And we are adding 3. And then we are taking away 2. That gives us 18. 17 plus 3 is 20, minus 2 is 18. So it's 18x to the 4th. And then more stuff. For x to the 6th, we have negative 2, and we're adding 10, which is 8. So plus 8x to the 6th. For x to the 10th, we just have plus 3. So plus 3x to the 10th. It was just 2, possibly 3. I mean, this you didn't have to do anything for the last one. But it's just a handful of arithmetic problems. Only combine them if they have the same number in front of them. Now, here's a problem where I think students just aren't getting this. Most students would jump on this problem. They would say 98 x's plus 2 x's is 100 x's. Now, you always have to understand that x is just a placeholder for a number. If this statement is true, then no matter what x is, 98 times whatever the value of x is, plus 2 times that same value of x, that equals to 100 times the value of x. Here, both of these are x terms, so 98 plus 2 is 100 x's. Now, somebody asks you when 98 times 7 plus 2 times 7, this is definitely not a time to say, oops, let me go run and get my calculator, because this is clearly a calculator problem. Or, oh, let me get pencil and paper, because I have to figure out what 98 times 7. You do not have to figure out what 98 times 7 is. Okay? If you do that, you're completely missing this problem. Think of this as a 7 term. This is a 7 term. It's also a 7 term. Think about 7, put units in, $7. Make believe that it's a $7 bill. Well, if you have 98 $7 bills and somebody's nice enough to give you 2 more $7 bills, don't you have 100 $7 bills? Now ignore the units. Possibly that putting in a unit helps. but they're really not there. And 100 times 7 is 700. I have no idea what that number is. At least I don't have to know what it is. I don't have to know what 2 times 7 is. 98 sevens plus 2 more sevens is 100 sevens. Okay, this is exactly what the line above is saying. Now to convince you this one more way. 98 times 7. That's 7 plus 7. 98 times. Let that represent 98 sevens. How many sevens you see here? You are not to say 3. There's many between those dots. Here are 98 sevens. And I am adding on 2 more sevens. 3 times. Well, how many times am I adding 7? 7 plus 7. How many times? 1, 2, 3, 4, 98, 99, 100 times. 7 plus 7, 100 times, the 100 times 7, which is 700. This is not a calculator problem. And if it is a calculator problem, it should be because you don't know what 100 times 7 is. The 98 sevens plus 2 sevens, well, 98 plus 2 is 100. It's 100 sevens. One last attempt to get you to see this. Factor out the 7. 7 times what gives you 98 times 7? Well, 7 times 98 is the same as 98 plus 7 times 7. Plus 7 times 2 is the same as 2 times 7, and 98 plus 2 is 100. 7 times 100 is 700. Next section will cover multiplication of polynomials. Good luck with this.